of the time, a Mosfet is the better and cheaper choice, as long as you pick a decent one. As always, thanks for watching, rate, comment, subscribe, use the Amazon affiliate links for your shopping. Here's my guide on solar.
Ha! I don't have to feel guilty this time getting a donation, since I'm actually working on technology right now, which is what my whole stream's supposed to be about, and I haven't been working on it for a while, so this time I actually deserve the bits, maybe. Sort of. Right now, okay. A Mosfet is an on-off switch, and it has some internal resistance. When it's off, the internal resistance is insanely high. When it's on, the internal resistance is fairly low, but still it's somewhat there. It's kind of like a resistor. Depending on how much power is surging through it, that small amount of resistance can still equate to a substantial amount of heat. So, I mean, a MOSFET is a type of transistor, and transistors, when grouped into millions, form processors. And as you know, processors need a heatsink and a fan or else they burn out. It's the same concept, except a MOSFET's just a giant transistor by itself. It's not a million of tiny ones all grouped together. So, yeah, if you have a MOSFET that's going to be, you know, a really important part of your power supply, you've got to put a heatsink on it. And I'm just kind of like, the only examples I have of this, guys, is some, like, boards that I stole from big screen TVs. You can see what they did, and that's kind of all I have to go on. It's like, I don't really know. I'd have to read a book on it or something. And there's no way I'm going to, like, figure out the right way. So you can see right here is a MOSFET. You can see it. And they put a little screw in the top of it, and you can see the thermal paste. It's white. That helps transfer the heat from the back of this thing into this heatsink. Now this heatsink has 3 fins here and 3 here. That increases the surface area of the metal in order to dissipate the heat that builds up in this metal more so. And then if you look at the back side of that same heatsink, you can see a whole bunch more fins. Each of those fins add more heat dissipation. The bottom of the heatsink, you can see they soldered it down here and here. So it actually has pins coming out the bottom of it. So I'm thinking I'll probably just take the heat sinks off of this board or one of my other boards and use it for my power supply. Here's the MOSFETs unheat synced on my power supply, and I need to add heat sinks to them. They're naked without heat sinks. They'll probably overheat. So that's kind of where we're at, but I figured before just YOLO taking a MOSFET heatsink off a board and just hoping it's big enough, hoping it's proper for my stuff, I figured I would maybe watch a couple YouTube videos, see what people have to say about heatsink stuff, you know? Just do my due diligence. That's what this is all about. Take it as a time to learn a little bit before just jumping right in, YOLO style. Because I really am ignorant, and I don't want to get into the math. I don't think it's worth it. I'd rather just touch it and see how hot it's getting, and just be very non-scientific about it. I don't want to get bogged down into the details of like how to calculate exactly how much heat and what's within specs and stuff. I feel like just getting heavily into all the mathematics of that would just be like really overkill. I don't think it's necessary. I think you just pick a heatsink way bigger than what you probably need and you're good. And no, it's not for my dad's TV. People throw away big screen TVs all the time because they're buying flat screen monitors nowadays, LCDs and HD TVs. So all the projector TVs from the past are getting set out for the trash. And whenever I'm passing through a town and I see a TV on the side of the road ready for the garbage man to pick up, I've now had a couple instances where I've taken that TV apart at home. I brought it home and I took it apart and stole all the parts from it. Actually, maybe even... No, there's been 3! I've done that to 3 TVs. And I get so much good stuff out of these TVs. Wiring and boards that have really good heat sinks on them and transistors, and they have transformers and huge capacitors, electrolytic capacitors, and you get to see like how they engineered everything, and they have a lot of electrical connectors on them and diodes. They're just like a treasure trove of parts. Yeah, it's a way of dumpster diving, but I'd call it like curb diving. You just take it off the side of the road, load it in your car. Or if it's a neighbor that lives right by you, you just walk to their garbage and you open it up and you look through it. If you see something good, you just reach down in there. Sometimes you fall in and you have to wait till somebody comes and get you, and you're head first in their trash when they get home from work, and they'll pull you up by the ankles and help you get out. That's happened several times. It can be very difficult to just rest in a headstand inside a garbage all day, but it's worth it to get free stuff, so. How did you get modded? Did Nightbot and you just form some kind of alliance against me? What the heck? Aha! This is what I needed to know. The top part of the Mosfet is called the drain. Oh, snaps. That's the drain? Gate is on the left. Drain is the middle. Oh, man. Yeah, as long as the stream title is somewhat relevant, it could be something a little bit funny. Anything other than the usual. We need something besides the usual. This is, after all, a special occasion. Me actually working on the robot. That's a big deal. Okay, so the drain is the top of this, and then this drain is also the top of that. Wait a minute. The center one? No, that's the source. We can't have this one's drain hitting his own source, which would be that. That'd be a short circuit. Yeah, that's a short circuit. So we can't have the heat sinks touch each other. That's what I just discovered. The heat sink of this one cannot touch the heat sink of this one, even though on my board these are right next to each other. So that's going to be an issue. There we go. Well, I just don't know, man. How big of a heatsink we need, you know? Grr. Well, I guess we'll take this one and we'll cut it in half. How about that? Does that sound good? You guys like that? Alright. That's what we'll do then. Oh, this is gonna be a mess. Okay, okay. First I need a screwdriver. Oh, that's not the right screwdriver. Why doesn't my screwdriver go into this? What kind of fancy pants screwdriver do I need? Uh-oh. I don't want to strip it. This is kind of a loose fit. I better go with something better because I want a snug fit because these screws seem like they're really in there good. Seems like it's going to be hard to unscrew. Like, oh, that's a good fit. They put the screws on super tight. Came right out. Very nice. Isn't it funny that I've been spending like a year, no, like a year and a half building this power supply? I could have just bought one for like $20. It says making a bomb robot, like that robot's the bomb, right? I thought it was a cute title, but I don't know if that's gonna get the FBI looking into me. it's a play on words, right? Because it kind of looks like I'm building a bomb, but it's like clickbait. I laughed. But I don't know if somebody at Twitch headquarters will take it seriously and think I'm actually building a bomb or something. That could be bad. They'll probably ban me. That would not be good. I'm going to use my fume extractor for this. Yes. That's what we built it for, boys. You dirty dog. You dirty dog. There we go. All right, we're trying to desolder. Reported. But you know I'm making a power supply for a robot that's gonna be the bomb. This robot's gonna be the bomb. Cool, it's making me look all high-tech having this blue lighting in the area. It makes my whole project look more legitimate. What the heck? Is my soldering iron hot? I guess so. Yeah, it's hot. I don't know why it won't. Oh, because it's a heat sink. It's a heat sink, so it's sinking the heat I put into it. What the heck? How do you desolder a heat sink then? Oh man. That's a question for the ages. How do you desolder a heatsink then? Do you need a 2000 degree soldering iron? I feel the whole heatsink getting hot from this. There's no way. There's no way I can... How in the heck do you desolder a heatsink? Seriously. I don't think this is possible. I'm gonna have to just like tear it off, honestly. There's no way I'm getting this thing off. Oh man. Hi, Console Cowboy. Woo! Breaking stuff now. Oh yeah, we're getting it. Just gotta manhandle it with a screwdriver. Well, I'm gonna get this heatsink. You better believe it. Turning this circuit board into potato chips. Yeah! Come get some. Okay. So that's how you properly remove a giant heatsink from an old board to reuse it. I don't know how you would solder this thing on. I'm just gonna glue it on or whatever. Like, there's no working with this type of stuff. I'm gonna vacuum myself off. Well, I don't know what to do. I'll flick it on the floor, I guess. It's not ruined! Okay, we have a heatsink. This can be used. It's not ruined. Can I cut it? My wife took my electronic side cutters. How the heck do her projects take priority over mine? I'm clipping off the little end things. Should I though? Maybe I shouldn't be. I don't know. The real question here, guys, is how do I want to use this for heat sinking 2 Mosfets, not 1. So I want to cut it in half. How do I cut this in half? How the heck do I cut this in half? I think there's only one way to do it. My angle grinder, right? Anything else would be insanity. Oh, goodness. This is gonna be a freaking huge job. Just to cut that in half is a lot of work. Obviously, you know, I gotta do what I gotta do, though. It's not like I have an option. I mean, unless if I should just do it. Well, I want to do this on stream. I could take it outside and do it, and not have to worry about the mess. But I mean, this is electronics. This is my bread and butter. My electronics videos for YouTube. I can't just abandon you guys and take the good stuff outside to do. I have to do it here where you guys can watch. I don't have a table saw. And I don't like using any kind of fancy tools. I like using common tools everyone else has. This way, people can follow along from home. Okay, shoot. Man, I wish I had a cutter that could cut through this, like a clipper, you know? But this is solid stuff. This is hardcore, hard aluminum. You gotta grind through it with a grinder. There's no other way. Alright, well, I'll do it. I'll do it then. I'm a man that's willing to do what it takes to make things happen. Safety glasses, of course. Vacuum chamber to catch the dust. I'm cutting this on stream, of course I am. When did you think I was gonna cut it? You guys think I'm lazy and I don't get stuff done, but that ain't true. I'm willing to do what it takes to get things done. I'm a hard worker, I make things happen. I'm a slow worker, but I'm very effective. Never count me out. Never count me out. I'll prove you wrong every time if you bet against me. Alright, so this is how you lose your fingers, guys. What the heck? Is it not plugged in? Oh, it is. It's getting hot. hot. I think I can just snap it in half now. Whew! It's real hot. Yeah! We did it, boys! Just like that, guys. Just like that. I'm gonna remove one fin from the center too. I'm making my own heat sinks. Ooh, it's hot! Or I'm making a smaller heat sink from a bigger heat sink. I'm making two smaller heat sinks from one bigger one. That's the aim. That's the goal. Oh man. Yeah, it worked. I'm tearing the fin off. Okay, now I can grind that smooth, and then I'll be able to mount the Mosfet on this. You can see it now. I cut it in half, and you can see I ground that smooth here. So it was like this at first. I cut it in half. But I want to put a heatsink like right here in the center of it, so I had to remove the center fin. So I ground it a little bit. You can see it, and now I'm going to grind this smooth. This way I can put the Mosfet right here, right in the center. So that's my next step to grind it smooth. It's not too bad, guys. Okay. Alright, that's done too now. Told you guys I could do it. Alright guys, I did it. I didn't make too bad of a mess, I don't think. Now I'm gonna put everything away and regroup. Plan out the next step, which I think will be trying to connect it to it. I don't think I need a screw though, right? Because I don't really want to drill and tap it or whatever. Like, I don't know. I've never actually drilled and tapped anything. I've seen it done a lot. Seems like it's not necessary to learn that to get the job done. What do you guys think? Can I just heat sink it right on? Like, as long as the heat sink's touching and everything's connected, can I just glue it on? Like, why do people screw a Mosfet on? That's my question. Thermal pad or paste? Yeah, I have thermal paste. My computer parts box. Okay, I'm just gonna like look at it for a second. These heat sinks can't touch one another. That's one issue right off the bat. So, this is just getting really interesting here. Actually, that was easy. Whoa. That was ridiculously easy. What the heck? I think I solved it already! Unbelievable. That was seriously the easiest thing ever. That'll work fine. Wow, it makes it look so cool too. Alright, so just get these little wires out of the way here. Oh. Okay. I want it to be there, so we'll just glue it into place with super glue and super glue activator. That shouldn't be an issue. I don't think. I bet you this thing's not gonna produce glue. I just know it. Generally does not produce glue the first attempt. The tip always gets filled with glue. Yep. Oh gosh, I almost stabbed myself. Alright, I just gotta remember there's two squares. It's lined up with the white line. I'm just gonna let go. Focus on just getting this stupid glue container open before we can move forward. Yeah! I pierced it. Alright. Should be good now. I'm excited, guys. I'm gonna be able to cross this off my to-do list, I bet. I'm attaching a heatsink, man. I made a heatsink from another heatsink of a decent size, I think. And I'm putting it on. What do you know? That wasn't so bad. Man. This glue's in no hurry to come out, is it? Oh, it's coming. It's barely trickling out. I'm probably gonna need to open up a new whole tube of glue. This one's on its last leg. No, thermal paste will be for connecting the part to the heatsink. But I'm just mounting the heatsink to the rest of the robot right now. That's plan A. Oh, I kind of like this glue being so syrupy. Yeah. That's what I'm talking about. I mean, there are many ways to do anything. I guess the pro way you would do it is you would somehow manage to connect the little pins at the bottom of the heatsink into one of these boards somehow and like solder it down. Instead of soldering it down, I'm just gluing it down. I think the strength of the connection of the heatsink to the board would be pretty comparable with gluing versus soldering. Pretty similar. Look how fast I did that. Because I uses the activator, that's the key. Activator makes super glue like the best kind of glue. But if you don't use the activator, it's like the worst glue because it's runny and it takes forever to dry. Like literally forever. It doesn't tack things in place. You have to hold it down the entire time it's drying. It's just a mess. But with the activator, it's like lives up to its name as being a super glue. You gotta get activator. I use Bob Smith Industries Accelerator Instaset for all CA glues. That stands for cyocrylanate, I believe. The active ingredient or the main ingredient of super glues. Yeah! Feeling it, man. That went very well. So now this this Mosfet can now be thermal paste onto here. You can see right here is a screw hole. It almost lines up. I mean, well, maybe I could just nudge things over a little bit and just screw it into the screw hole. I have the screw too. Well, shoot, I don't mind doing it that way. Might be fine. I just gotta I gotta remember not to screw it all the way in until I thermal paste it though. Yeah, it's going right in. That's pretty cool. That's pretty professional of me to actually screw it in. So that could work. Can't you read the title of my stream console to know what I'm making? My mod made my stream title. Did he give me a good stream title? I told him to describe in the title what I'm making. Alright, so pretty much I have to get up and get thermal paste. I don't keep it on hand. Maybe I should start though. Maybe I should start keeping thermal paste on hand. Because that's related to the stuff I'm getting into. I'm going to be using a lot of resistors, I mean not resistors, transistors which require heat sinks. So yeah, I think thermal paste is something I'll be using a lot more in the coming years and months. And so I should no longer just keep it in my PC building box, but actually keep it like in my electronics kit that I keep in arm's reach. See, this is why this shelf keeps getting busier and busier, because over time I add to it things that I might need. And it's all in arm's reach, so I don't have to do what I'm doing right now, which is to set everything aside and get up and go get parts. I hate having to get up. Like, it all should be within arm's reach. Alright guys, we got our Formula 5 thermal paste stuff from Entech. We're going to apply that to the back of the heatsink. Wait a minute. No, I shouldn't attach it yet. You know why? I'm not done soldering to it. If you attach the heatsink onto the Mosfet, you won't be able to solder it or anything anymore. Solder won't stick. I don't think. It might. Might not though. I don't trust it. But just having it in place is good enough. You know, we can always just stick it on with the thermal paste. No big deal. Alright, right now I'm just gluing the second heatsink into place, but we're not going to attach the Mosfets until all the soldering onto the Mosfets is done. So, yeah. I didn't think of that before. Am I sure it will work? Absolutely. I mean, the whole point is to have a piece of metal stick to your part. That way your part will dissipate heat better and not overheat. To make sure that the heatsink is working out correctly, we can just put our finger on the heatsink and see how hot it is. If it's not burning us, then it's probably fine. That's like the non-scientific way, I guess. Like, some people might do hardcore math and stuff, but meh. Okay, that super glue thing is gone, man. This is my new one. Yeah. There's not much place to put glue except this little tiny corner here. I'm gonna have to create a bridge from the board to the heatsink using hot glue. Hot glue is better for spanning gaps. And you know what the best part is? Just like the Hulk stays angry all the time, and that's why he's able to transition to Hulk state so fast and easy in the later Avengers movies, I keep my hot gun in hot state at all times, and that's why I'm able to hot glue things so quickly in the later Larry streams. I took a note from the Hulk. You just gotta be ready all the time, man. The hot glue gun is like my Hulk rage mode. I gotta have it ready. Even if that means maybe shortening the life of the gun, I don't know. I can't stand to have to wait to hot glue things. I want to hot glue now. When it's time to hot glue, I want it instant. No waiting around. Ain't nobody got time for that. Ooh, I almost knocked over this thing. That would have been bad. Oh no! I gotta move a little slower here. Okay. Now for the activator. No, I said the proper way to attach the heatsink would be to solder it, but that gluing it's fine. I don't oftentimes do it the proper way. Because it's not practical. Like if you're mass manufacturing, you would purposefully shape and design the heatsink to perfectly line up with your board, with the pinholes lining up with solder holes, and then you just pop it in and solder it. But when you're not dealing with custom designed parts, you have to use a more flexible method, and gluing's the most flexible thing you could do. You don't have to worry about things lining up or whatever. Solder holes lining up with whatever. It's unrealistic. Okay, so now we got two heat sinks, and you can see I put a little gap between them, and I can mount my two switching Mosfets for my buck converter onto them. I'm gonna have to move this one over quite a bit more to the right to make room. Well, I don't have to, but I'd like to, yeah, I'm going to. So that's up next. Oh my goodness. That'll work. Okay. So now I just moved the right one over a little bit so it could mount like that. Like that. Doesn't have to be centered perfectly, I don't think. As long as it's, you know, flush on the heatsink, the heat will draw away from it. It'll cool it down quite a bit. And we'll apply it with the thermal paste. But like I said, you won't be able to solder and desolder the heatsink at all once it's attached to, or you won't be able to solder and desolder the pins of the MOSFET once it's attached to the heatsink, because it will be cooled so quickly by the heatsink. Unless if you have a really hot soldering iron. That's my concern. So until all the pins of the MOSFET are fully connected, I'm not going to attach it to the heatsink until that point. Is this part of the robot? I mean, honestly, no. This is the power supply for my handheld vacuum. But I'll be making the same power supply 3 times. One for the robot, one for the vacuum, one for the CNC machine. So all my major projects require the same power supply, and so it's kind of like for the robot in the sense that it's a prototype and a proof of concept of my design for this power supply. Okay, I can't believe I get to cross this off. Add cooling fins to 2 main switching MOSFETs to prevent overheating. Literally, I just finished that. blown away right now that I just got that done. That's been on my to-do list for like 2 months. It's just so cool. And I originally wasn't going to have heat sinks, and then it hit me that I needed them. Oh, the hand vacuums ahead of the robot only because I need that vacuum, number one. And number two, it represents the first real electronics project I'll be completing. I mean, I've done a lot of electronics repairs since I started that, but it's my first major electronics project. And I started it while working on the robot on a different day of the week. But now that I'm done with everything I needed to do with the robot and I'm ready for its power supply, and I'm already building a power supply for my vacuum, I'm going to finish the power supply for the vacuum and then make the same power supply 2 more times, once for the CNC machine and once for the robot. So the robot, the CNC machine, and the vacuum all require power supply, and they're all waiting for that as the next step. So that's why I'm building 3 of them, and the first one is already planned to go onto the vacuum. Also, for you to say that I should put the power supply for my vacuum, which I need on a daily basis and haven't had for like 2 years now, I disagree with you, because the robot is a 15-year project. So you're saying I should just not work on the vacuum at all for 15 years? Like, people need a vacuum during their 15 years. They can't just have no vacuum. Adam can't just flat out be first. I can't put my whole life on hold for 15 years or 20 years. Like, Adam's going to be woven into the rest of my work. He can't just be the only thing I do. You don't realize how YouTube works. You need to have a large amount of content to slowly drive in more of an audience and build up your YouTube channel. My YouTube channel's growing explosively. I have 1,350 subscribers now. 4 months ago, I was struggling to get my first 1,000. I'm well on my way to my next 1,000. It's growing fast. I'm averaging between 2 to 5 subscribers per day. I'm making between $100 and $200 a month. I believe it's gonna hit the $200 a month amount during this holiday season, or really close to it. And this is just the beginning. My channel's really starting to pick up some steam here, and I believe I'm gonna be able to get it to the $500, $600, $800 a month. It's a substantial part of my plan to make money while I work on things I enjoy to do. I only spend an hour and a half on YouTube per day. It is a lot of time, but an hour and a half per day is going to be well worth it once the channel starts making me like 1,000 a month or more. That's going to be crazy. I don't get 50 views a video. I have like 50,000 views a month. You're telling me you think I only get like 200 views a month? I get like 50,000 views a month on my channel. Most of the money I make from my YouTube channel is from videos a minimum of 1 to 2 years old. The videos I release that get 20 or 30 views when they're first released don't make me any money. They might make me 1 penny. But after 1 or 2 or 3 years go by, that 50 view video can start creeping up into 100, then 200, then 300. Next thing you know, it's got 20, 30, 40,000 views on it. But they start off very slow. and they creep up over time. That's how my videos perform. They don't get front-loaded views like PewDiePie. He gets 8 million views on a video the day he releases it, and then it doesn't get another view after that. It might get 10,000 views over the next 6 years. And people just watch his latest video. That's not how my channel works. I have a DIY channel. My videos pick up steam and momentum over many years. They make more money the older they are. They age like fine wine. That's just how it is for my channel. I don't just sit there eating. I've done all kinds of automotive repairs, electronics repairs, building things, fixing things, tailoring things, planning things, sanding things, cutting things, designing things, coding things, describing things, teaching things, outlining things. Just because I'm doing it all from one chair doesn't mean I'm not doing a lot of stuff. Well, that was a little bit anticlimactic for an electronics day, I have to tell you. I didn't get that much done, but I did get some hard stuff done. I was kind of dreading putting together a heatsink solution. I didn't know what to do. Never done it before. So the fact that I figured it out and I just did it, including fabricating the metal, that's pretty impressive. I did that pretty fast, right? All things considered. Thanks to that awesome hand grinder tool. My very next step will be to continue the work on my custom Arduino board here. You can see the microcontroller here, a bunch of little discrete components here. I have to continue with that build, and all the parts I need for that are all in this bag. But I don't think I can get into that today. My allotted time for streaming is already over for the day. So, yeah, I can't start something major new right now. I guess, yeah, it might seem a little disappointing to you guys, and to me too, that it didn't seem like I got like a lot done, especially when I haven't had an electronics day for so long. But you can't always get huge progress every time you work on something. Sometimes it's going to be a baby step, but we did get to cross something substantial off. And by substantial, I mean not only like difficult, but something I've never done before, and something I had doubts about and didn't know how I was going to approach. And I was able to figure it out on the spot and deliver and execute at a high level in real time while you guys watch, and I totally nailed it, and I did a great job. So I gotta be proud of that. And we can just put our little bag of electronics now away and put everything away and call it a victory. And come back. The next electronics day will be in like a few days, so it's not that big of a deal. I think it should be in a few days. I mean, I might have said that and then not done electronics for 3 weeks last time. I don't know. But theoretically, it should be in a few days. So, yeah.